Good morning, grade 10s.
Morning, ma'am.
How are you?
Good, and yourself?
I'm good. Okay, what are triangles?
Triangles, they are shapes with three sides and three angles.
Okay, you're correct. They are closed geometric figures with three sides and three angles. Can you please name the types of triangles?
Okay, so you get the isosceles, the right angle triangle, and the scalene one.
Okay, we have 6 types of triangles, which is the isosceles, the equilateral, and the scalene. Those are used for sides. And we also have the acute, the right angle, and the obtuse. These are used for angles.
Okay.
Okay, can you please come label the triangle?
Okay, I'll use the purple. Say that is A, that is B, this C. It's a right angle.
Which one of these sides is the hypotenuse?
Okay, so the hypotenuse is the one that's like opposite the right angle sign, so it will be this one.
Okay. So now, in the previous grades, you learned how to find unknown sides using the Pythagoras theorem, right? So now we're going to recap how to find unknown sides using the Pythagoras theorem. So let's say now this is 8 centimeters and this is 5 centimeters. So now we're going to find the hypotenuse side. Ne? So we're going to say a squared plus b squared is equal to c squared. This is our formula for Pythagoras. So you're going to give an explanation that you use the Pythagoras theorem when you calculated the unknown side. So now this is our A, 8 centimeters squared, plus our B is 5 centimeters squared, and C is used to find the hypotenuse. So it's gonna be C squared. We're gonna leave it at that. So we're going to calculate. When you punch this on the calculator, what does it give you?
8 squared is 64.
64.
And 5 squared is 100.
100. And then you're gonna add them up, right?
Yes.
So it's gonna be 164 is equal to 6 squared. Then to get rid of the squared, you're gonna put your root there.
Yes.
Then C is going to remain as it is, and then you're gonna, what's the answer when you punch this on your calculator?
The square root of 164 is 2 root 41.
2 root 41.
Yes, which is 12,8.
So our hypotenuse side is 12,8 centimeters. Okay.
Okay.
Okay, now, what is trigonometry? Trigonometry is geometrical constructions where the ratio of sides' length is used to determine angular measurement. It is divided into 2 parts, which is trigon and metric. Trigon is the triangle and metric is the measurement.
Okay, so in this unit we are going to focus on the basics of trigonometry. So trigonometry uses the basic right angle triangle. Okay, so let's look at the one we labeled over here. So say for example, this is your triangle. You have side AC, then you have side BC, and then you have side AB. And remember, AB is the hypotenuse. Okay, so say for example, you place yourself over, okay, let's use it now. Let's say you place yourself over here, like how it's shown. This is called theta, okay? So that's you. So if you place yourself here, we're going to look which is on your opposite side. Okay, if you are inside the triangle, you're looking here. Let's try and figure that out.
The opposite side is AC.
AC. So let's just label this opposite, okay? I'm going to just put it in short, okay? And then you have the adjacent side. Adjacent means next to. So which side is the one next to you?
BC.
BC. So this one here is
the adjacent
side. Okay. So for example, I'm no more here. I move away from here. I normally live here. I go and stay here. Now, which is the opposite side?
BC.
Okay, BC is opposite to A, so this will be the opposite side. And then
AC is going to be our adjacent side.
Okay, yes. AC is going to be the one that is adjacent. Alright. So, now that we know how to move around in our triangle, let's look at the three main rules of trigonometry, okay? So, they are called ratios, okay? So, we have the sine ratio. So, the sine ratio is also as abbreviated sin, okay? So, you say sin theta, which is u basically, the angle in the triangle, is opposite over hypotenuse. So if you want to figure out sine, you're going to use the opposite side and the hypotenuse, this one here. Okay, I will explain with examples just now. Then we have the cosine ratio. So the cosine is as abbreviated here, cos with theta, that is the angle measurement. It's adjacent over the hypotenuse. So the adjacent would be over here and then the hypotenuse. Okay. Now what's left is the third one, which is called tangent. So tangent, abbreviated tan, is the opposite side over the adjacent side. Alright. So let's look at examples. Let's look at one for sine. Alright. You want to pick an apple from a tree in your backyard, okay? And the apples are too high for you to reach. So now you bring a 2-meter ladder and then you place it 30 degrees to reach the tree where the ripe apples are. Now, how far actually are the apples from the ground, okay? So now that's too much information. So let's look at a picture to visualize this easier, okay? So there is you over there, alright? There you brought a tree, there is your ripe apples, and there is the ground, okay? So you placed it 30 degrees, here is your sine. So now you want to know this part, right? How big is the tree, or rather how high it is from here. So we're going to use trigonometry for that, okay? So let's use something like this again. Okay, so there we have you of there's your ladder, here's your tree, we have your A, we have your B, and we have your C. What is the information that we know?
We know that the ladder is 2 meters.
Okay, so we know that this part here is 2 meters. And what else?
We also know that it's placed at 30 degrees.
Yes, so if it's placed at 30 degrees, that means this angle here is 30 degrees. Okay? So what we're going to do is use the sine rule to find this part here. So what is the sine rule? So you say sine theta is equals to
opposite side over hypotenuse.
The opposite over the hypotenuse, right? Okay, so what is the opposite side here?
The opposite side is x.
Okay, because if we are standing here, the opposite side would be
the AC,
and that is what we want to find out. So we can just say AC or x or whatever you want it. And then we're looking at the hypotenuse. Now the hypotenuse is 2 meters. And here we have sine, and sine is how big? 30 degrees, okay? Over 1. Alright. So what are we going to do now? We are going to cross multiply. Okay, so let's do it this way first. AC times 1 is obviously AC. And then sine 30 degrees times 2 meters will be 2 meters sine 30 degrees. Okay. Now you take out your calculator and you're going to punch in 2 sine 30 degrees. Okay, take out your calculators. Okay, you press the sine 2 and then the sine 30 degrees. Yes, and what did you get?
1.
Okay, so AC would be 1 meter. Okay, there it is, 1 meter. So that's how you can find out, knowing what the third side without even having the second side. Alright, let's look at another example. Say Andile, she stands from the ground floor outside a building, and the door to enter the building is on the first floor. Some places to enter the building you have to like climb stairs, and then there'll be the door there. So the stairs, they start 2 meters away from the building, okay? And the building, and it increases at 55 degrees. Now, how long are the stairs? That is what the people want to know here. Let's use the triangle again. Visualize it. See, here we are. Let me show you a picture. Here's it. See? You see a little stairs here, and then the stairs are 2 meters away from the building. And now they want to know how long the stairs are. So, we know that the stairs are 55-degree angle. Here we have 55 degrees. We want to know how long this path is. And we know that from the building, Andile, who is B, she's going to stand here. And she's standing how far?
2 meters.
2 meters. Okay. So now how will we find out how long the stairs are? Okay. So we're going to use the cosine rule. So the cosine rule is cosine theta is equals to the
adjacent side over the hypotenuse.
The adjacent over the hypotenuse. Okay. Just gonna abbreviate it there. So if we are standing at 55 degrees, so if cos is 55 degrees over 1, what is the adjacent side?
BC.
BC, which is
2 meters.
2 meters over what is the hypotenuse?
AB.
AB. We don't know, right? So now we're gonna again do what?
Cross multiply.
Cross multiply. So we have here okay. So it's AB cos 55 is equals to 2 meters, okay? Okay, let me carry on there because I believe you won't be able to see, okay? So AB cos 55 degrees, right? So now we want to take away the AB because we want to find AB. So what are we going to do?
We're going to divide with cos 55 on both sides.
On both sides, right. So this here divided by cos 55, and this here also divided by cos 55. Okay. So here we are left with AB is equals to 2 meters divided by
cos 55.
Cos 55. Okay. So now you can punch this into the calculator. So it's 2 meters using that fraction sign there. So you have 2 meters over cos 55, which is, who can give me the answer?
It's 3,48.
3,48 blah blah blah. So you can just round it off to
3,47.
Yes. Okay, so now we know that AB is 3,49 meters. Yes. Okay. Now let's look at another example. You are on a boat that takes you to the Statue of Liberty. Okay, so Statue of Liberty is this monument in America. I'm sure you guys have seen it in movies or pictures somewhere. It's also one of the wonders of the world. So if you know that thing is like in the middle, it's on a little island, and to go to it you need a boat. Okay, so say you go on a boat for it, right? And the guy tells you that you are now 100 meters away from the Statue of Liberty, right? And then you look up at an angle of 25 degrees and you wonder how high the statue is, right? How are you going to calculate that? You want to know right then, okay? So there's a little visual example. Here's you on the little boat, and this is 100 meters away. And now you're looking at exactly 25 degrees up, and you're looking to the top there. Alright. Now, let's put it here onto the board again. Okay. Let's just take this one off. So you're looking this way. This is how high it is, and that's how far you are. So let's again label it A, B, and C. We have a little right angle there. Okay, and then we know that we are looking exactly
25 degrees.
25 degrees up, right? And what other information do we know?
We know that from the Statue of Liberty to where you are, it's 100 meters.
Yes. So there we have 100 meters, and then there's the little Statue of Liberty. Now you want to know where this little torch is, okay? So let's use the tan rule to find this out, okay? So we know tan theta is equals to
Opposite side over adjacent side.
it's the opposite side over the adjacent side, right? So now if you are standing here, which is the opposite side? Again,
AC.
AC. And which is the adjacent side?
BC.
BC, which is
100 meters.
100 meters. And we have here 10, which is 25 degrees. Okay, over 1. Then again we are back to cross multiply. So it will be again AC is equals to
100 tan 25 degrees.
yes. So now again, if you can like maybe punch that into the calculator, 125 will be
46,63.
okay. So it's 46,63. So meters high. So now you know how high the Statue of Liberty is. Okay. So say for example, if you want to tell someone, someone asks you right there in the boat that how high is the Statue of Liberty? So you're not going to say 46,63 meters. You might just say 47 meters. Okay. You want to give a whole number. So in your exams or in your tests, they might ask you whole numbers or round off to 2 digits or round off to 3 or 1 place. Then you know how to do it. Okay.
Okay, so now we're going to look at different examples for your classwork. The first one says you are 1.7 meters tall. You are flying a kite, holding at a 45-degree angle. The distance from where you are standing to a kite is 1.5 meters. The kite is 3.8 meters high. Now determine the length of the kite. Okay, so using our triangle, this is where you are standing, right? Then they say that you are 1.7 meters tall. Okay, so now this is where the kite is flying from there. It's flying from which angle?
45 degree.
45 degrees. So now you want to know from where you are standing and from where the kite is. It's a distance of 1.5 meters. So now we want to know the length of the kite, because the kite, it says that it's 3.8 meters high. So now we want to find the length of the kite. So which rule are you going to use? Which rule do you think you're going to use?
Okay. We can maybe use Pythagoras.
Okay.
If we have that, or we can use the sine one.
Okay, you can either use the sine, the cos, or the Pythagoras theorem.
Okay.
So if now you're going to use the cos, you're going to say the adjacent over the hypotenuse, or you can use the sine, use this one, or rather use Pythagoras.
Okay.
Use the Pythagoras theorem. Okay, now you can. Okay, let's go to the other questions. And the second one says, add 57 inches from the base or from the base of a building. You need to look up at 55 degrees to see the top of the building. What is the height of the building? So now you're gonna find the height of the building. Now you have your you're looking up the building with 55 degrees to see the top, and the base of the building is 57 inches. So now you need to find how long the building is. So now you're going to find the height of the building. And then the third one says, a nursery plants a new tree and attaches a guy wire to help support the tree while its roots take hold. An 8-foot wire is attached to the tree and to a stake in the ground. From the stake in the ground, the angle of elevation of the connection with the tree is 42 degrees. Find to the nearest tenth of a foot the height of the connection to the connection point on the tree. So now you wanna know. You don't want to know how high your tree is. You just want to know that from the point this wire is holding the tree from the ground to that point. You want to know how high this is. So now you're going to do your homework. Okay. No, that it's a classwork. You're doing it now. So if you have any questions regarding the classwork, you're gonna ask, but do it now. So now, next week, we're going to look at finding the angles using the same ratios, your sin, your cos, and your tan. Okay, and then this is your homework. Please complete it for me, and we'll mark it next week together with the classwork.